All right, guys, I'm going to go ahead and get started. So, my name is Dave Alonso. I'm one of the organizers for the meetup, and we also have Fred Evans. He will be here in probably a few minutes. He's a little late. And today we're going to be doing a OpenShift 101. And I was going to be deploying Red Hat because, I wanted to show how OpenShift is actually deployed. But because of the limited time, we're probably going to leave that out for now, and I might just do a quick demo of my local mini-shift or OpenShift environment. We've also got George Morgan and Matt Wilkerson from Red Hat. They're going to be doing the majority of the presentation today. Let's see, here's the agenda. So we're going to do the 101 brief, and I'm going to go over, after that's done, it'll be about an hour. I'm going to do a security tools briefing on various tools that integrate with OpenShift and what they do in terms of security. And I'm going to talk about our managed service offering for Dell Technologies. And then we can do a Q&A session if anybody has any questions about the platform or the tools that I mentioned or anything at all about containers and managing container environments. Like I said, I'm Dave Alonso. It's my LinkedIn. Fred Evans and his LinkedIn. And the purpose of this meetup, we started it because we wanted to share new trends in cloud, technologies, industry best practices. So we encourage everyone to participate. If you have any topics you would like to talk about or you'd like to hear about, please let us know. And the other main reason is myself and my business partner found it hard to keep up with a lot of the technologies that are coming out. It seems like everything's changing so much every day that you really need a quick way to get as much information as you can and figure out which direction you want to go. So we're hoping to get feedback from as many people in industry as possible that can, help speed up that learning process. As I mentioned, we have George Morgan, Senior Solutions Architect with Red Hat, and Matthew Wilkerson, Senior Solutions Architect. And do both of you guys work public sector, or is it just Matt?
Yeah, no, we both work public sector. I'm on the partner channel, supporting some of our managed service providers, and as well as our Microsoft Azure partnership. And Matt, I'll let you chime in here as well.
Okay. Yep, we're on the same team. So public sector, I support partners as well. So anything public sector across the U.S. really.
Awesome. Thanks, guys, again for joining and giving us this slide deck today. So we can go ahead and get started. I'm going to go ahead and cancel my screen share and then make you guys presenters.
Okay.
George, do you want me to pass it off to you?
Yeah, I'm actually just starting to share my screen right now. Just one moment.
Okay.
Are you?
All right, you can see it.
Great. It just takes a second to load. Can everybody see the first slide?
I do.
Yep.
Yep.
All right, excellent. Well, Dave, I really appreciate you having myself and Matt this afternoon. I know it's towards the end of the workday, and the last thing people want to be exposed to is a presentation slide deck. We're coming off the end of the day. We're trying to decompress, and we have family in the background. So please feel free to if you have any questions throughout the presentation, please let us know. Just to give you a quick overview, my specialty is definitely around the go-to-market strategy when it comes to OpenShift, and a lot of the value proposition around the OpenShift offering. And what I'm going to do is I'm going to kick this off, go through a few slides, and pass it over to Matt, who will do a little bit more on the technical side of things, and then I'll come back and wrap us up. So with that, One second. Oh, I might have just lost my screen. One second. I apologize. There we go. Okay, so why don't we just go ahead and get started. Now, before I actually start talking about OpenShift and how great OpenShift is and start talking about technologies, I kind of want to take a step back and kind of focus more on the why we're having this discussion. And a lot of that has to do with business innovation. And with that in mind, business is moving faster than ever before. Today we can do things that we basically couldn't have dreamed of a few years ago. And not only that, but technology and especially open source communities, are introducing or have already introduced ways where different groups of people can collaborate on projects and start to leverage the power of open source to continuously drive additional innovation within those projects. And today we're no longer looking at startups, Web 2.0 companies like Facebook, Uber, and Airbnb for inspiration. Today, every organization, all over the world, any industry can innovate, by creating customer value and differentiation to basically be able to compete on an equal playing field. And with Red Hat OpenShift, we're building on our heritage of, Red Hat Enterprise Linux. Oftentimes when, we ask people, what do you know us for? They'll always, most cases, they'll say, well, you guys make operating systems, and which is true. And we've been doing that for 25 plus years. But with that, we've taken away a lot of our, lessons and sort of channeled a lot of those lessons learned into some of the other enterprise emerging technology type products that we've been offering, including OpenShift. So we like to say that a lot of our offerings are built on top of Red Hat Enterprise Linux, and a lot of that, those lessons learned will bubble up into a lot of our other product offerings. So why is it being able to move faster and innovate so important? Well, at the end of the day, what we're hearing from our customers around the world is, the ability to create value for their end customers, both, internally and externally, depends on one thing, and that is being able to develop or deliver applications faster. It's really, your ability to, get a great application development and app delivery mechanism to really, differentiate yourself from the competition, engage customers, and find a way to create value that at the end of the day, you can actually turn into additional revenue. Now, I'm also going to talk about, containers and Kubernetes, that fundamentally enable, DevOps. These are all like buzz phrases that we've seen, or buzzwords that we've seen in the last few years. That you've got DevOps. If you're more security minded, DevOps has sort of transitioned more into what's called DevSecOps, microservices. So what I want to do as part of this discussion, and one of the pitfalls I want to sort of avoid that I've seen time and time again, is putting the cart before the horse, talking about OpenShift, but not really laying the foundation for what are some of those pieces that have led us to being able to provide that OpenShift kind of platform that's going to help you create applications faster. So just real quick, this is kind of a spoiler for the rest of the presentation. OpenShift is going to be that unique platform to help you, develop those applications faster. So containers, Kubernetes, DevOps, these are all, the key ingredients that, a modern application platform should be based on, and allows you to transform, your traditional monolithic apps to build, cloud native applications, and also experiment with cool things like analytics, machine learning, serverless applications. And this application, OpenShift or any container platform needs to be able to provide a consistent way for both developers and operations teams to basically collaborate across, all deployment footprints. We're seeing, if anything, in the last 5 years, we've seen an uptick of, hybrid cloud. We're always customers are saying, I'm getting told by management that I need to be able to move applications between different environments, between a public cloud or maybe an on-premise cloud. And because a lot of concepts around containers and Kubernetes and the decoupling of some of those underlying requirements on the infrastructure sort of provides a good foundation for being able to provide those applications across multiple clouds. This is one of our, handy dandy marketing slides. We've got a whole bunch of, Red Hat likes to tout all the customers that we support, and as you can see, there's a plethora across the different use cases, as you glance through the slide, you see, notable companies, and then, they're using OpenShift to address a lot of their digital transformation requirements. So I didn't want to turn this presentation into, this is so great, this customer A did this, customer B did that. I sort of just use this as an opportunity to give you an idea of the customer landscape. And if there are any questions, or if you would like to hear, or if you'd like to get documentation, use case or case study documentation, I can definitely provide that after today's session.
Hey, George.
Yeah.
I'm not sure you're on the right slide, or if you're showing different customers on your slide.
Oh, okay. What slide are you seeing?
Now I'm seeing the one you were talking about. There we go.
Oh, okay. It must be there must be a delay in the presentation.
Gotcha.
All right. So let's go to the next one. So let me know when it shifts over. Do you see the why customers choose Red Hat OpenShift? It's still stuck on the previous one.
It's still stuck on the previous one, yeah.
The hamster needs to spin faster to get the next slide up. All right, well, I'm just going to start talking. And,
yeah, that's fine.
Yeah, it'll pop up. So when it comes to, why customers choose Red Hat OpenShift, so, we basically built OpenShift from 4 basic guiding principles. And when the slide shows up, you'll see what I'm talking about. But there's a bar at the bottom of the slide that talks about open source innovation. So, innovation is happening all the time in open source projects, communities, call them what you will. And, Red Hat, across all of the Red Hat offerings, each of those offerings leverage at least one, sometimes, many different projects. And what's great is that we're staying abreast of all the changes that are happening in those communities, but also making sure that when we're packaging a lot of these, new innovative capabilities, we're making sure that it's in a trusted enterprise, production-ready kind of packaging. In terms of Kubernetes, we'll talk a little bit here about what we call trusted Kubernetes. So not only, if anybody has ever installed Kubernetes or configured it or tried to maintain it, you're going to find out very quickly that Kubernetes is very hard. You have to stay abreast of a lot of different pieces, parts, and make sure that, when new updates come on, you need to be able to address and apply them to your Kubernetes environment. But with regards to OpenShift, we've sort of taken a lot of that, overhead and a lot of that management, a lot of those headaches. And not only have we streamlined a lot of those features or a lot of those operations, but we've also encapsulated within a lot of our previous knowledge when it comes to security, because of the fact that OpenShift, which also leverages Red Hat Enterprise Linux and a lot of the security benefits that we've implemented over the years with Linux, those basically have been incorporated as part of the Kubernetes, the trusted Kubernetes offering within OpenShift. Are you guys seeing the slide yet, or is it still on the?
Yeah, it's still on the customer side. I think maybe you're just behind one, and so if you go forward again, you'll probably be on the slide you were just talking about.
Wow. Okay. Never seen that before, but okay.
Okay, now you're on the one you were just talking about.
Now we see,
So
but
like
before we talk.
So it's got a good 1 or 2 minute delay. That's awesome. All right.
So
Well,
George,
switch to the next
it shows
one.
but before we talk, or it did.
What's that?
It shows why customers choose Red Hat. Is it showing you one ahead of what we're seeing? Now we see but before we talk.
I just switched back to why customers choose Red Hat OpenShift.
Okay. Maybe it's just incredibly slow, I guess, huh?
Yeah, I don't know. All right.
Now
so
we see why customers choose Red Hat.
All right. So now I just switched. So it looks like it's got like a 30-second delay.
Okay.
All right. So before we get started, wanted to just get an idea from the audience. What have you? How familiar is everyone with containers, Kubernetes? Is this something that we like us to talk a little bit about, just to sort of set the stage for the OpenShift discussion? Or I just always want to make sure that before we put the cart before the horse, that we understand where we are in terms of the overall level of understanding.
I'm good with it. I understand containerization, and Kubernetes is my pain, honestly.
Gotcha.
Hey, George, I think it's roughly half. I asked a question, but before the meetup, I did an RSVP question, and it's probably about 50-50 so far.
Okay. Well, you know what? I'll go through the slides, and then if there are any questions that come up, Matt and I will tackle them as needed.
And if people had questions, you can put them in the chat, and we'll try to monitor as well.
Yeah, I was just going to suggest that. That's probably the best way, so you guys can just get to it when you can.
Okay, great. That works. So why containers? And there's a few things I want to touch on here. Now, the concept of the container, you can argue has been around for quite a while. You could say it goes back as far back as Solaris zones, or even before then. But the way the modern container sort of introduces this new paradigm for developing and deploying applications, primarily when it comes to reducing application load time, so being able to cut down on the amount of time. Sorry, is there a question? Okay. So being able to reduce application load times, improving the ability to spin up, spin down new applications. So the way to think of a container, it's a process that's running on the system or on your cloud, and you have a lot more lightweight packaging when it comes to the containers themselves. So therefore, you get a more reduced, like a resource footprint, because certain components need to be run in the container itself. So the container will typically have the libraries it needs, the runtimes, and any other OS dependencies, while at the same time sharing the container cluster, kernel across the different containers running on the environment. All dependencies are taken care of in the container. It's immutable, so you've got a consistent, predictable footprint across applications. So being able to make sure that future testing and QA becomes less error prone, because you have a lot more pre-established packaging within the container to prevent any kind of issues when it comes to that. And not only that, but increased portability. This sort of is very important when you're especially talking within the context of a hybrid cloud environment, being able to move containers across different public, private cloud offerings, because at the end of the day, the container does not really care what the underlying infrastructure looks like. At the end of the day, it'll run, just as well as obviously resources. As long as there are no, discrepancies in underlying resources, a container will run just as well on a bare metal environment versus a public cloud, and so on and so forth. What are containers? Well, it depends on who you ask. So basically, development, dev teams look at it more as a packaged app runtime. So being able to focus primarily on what the application teams do best. Ops obviously are going to look at it more from the perspective of, processes that are isolated, that may share a kernel, but at the end of the day are isolated from each other. It's kind of complementary to virtual machines. They fit in very different circumstances, and just in general, just simpler, lighter, and denser than VMs. And this just gives you a good, illustration on a comparison between virtual machines and containers. On the left-hand side, assuming that this slide has caught up to where I am at, you have virtual machines on the left-hand side. You have containers on the right. Virtual machines are a lot denser. They have typically more applications running out on them, and then they all, have the same kernel. And then you've got obviously the hypervisor and the underlying hardware. Whereas containers, in the green, are more self-contained. Have all the things they need to run the application, and any of those OS dependencies as well.
Hey, George, do you mind trying to go ahead one more slide, because you're still on 11, just to see it? Okay, so now you're on the slide you were just talking about.
Gotcha. Okay. So yeah, basically, what I was saying before is that you've got the virtual machines on the left, and in purple, those are all the dependencies and all the things that come with the VM. And on the right, you've got containers that are more self-contained when it comes to the application runtimes, the libraries, and the OS dependencies. And at the end of the day, they're sharing the same container host kernel. So. Okay. So now I've switched slides. I'm wondering if it makes sense, and sorry to pause you for just a second, Dave, but does everybody have like a copy of this? Were you able to send out the copy of the slide deck, and maybe it'd be easier if people follow along from their own?
No, I mean, the slide changed, and I do have a copy of it. So I can send it out afterwards if you'd like. And I wasn't sure if you guys had changed the slides at all. But yeah, you're on the right slide now. You're on the one right after.
Okay, great. Awesome. So, this is how we address the whole container adoption challenges in OpenShift, and overall what the value at the end of the day that OpenShift provides in each of these categories. So, like I said before, we take container security very seriously. We kind of take a holistic approach and deliver what we like to call the enterprise Kubernetes platform. And as you know, containers are Linux, and so is Kubernetes. And because we also provide RHEL, or Red Hat Enterprise Linux, we can deliver a secure platform across the stack, and stand behind it with Red Hat support and so on and so forth. But we also recognize that keeping up to date with frequent upstream releases can be very challenging, especially if you're running vanilla Kubernetes, and being able to have an automated way to be able to update your clusters using what we call the over-the-air updates feature to basically stay abreast of all the latest and greatest innovations that come about from the Red Hat team when it comes to OpenShift. So at the end of the day, I mean, it's all about developers, and we're investing, in automation capabilities in OpenShift, CI/CD pipeline, so continuous integration, continuous delivery, dev tools like code-ready workspaces, and as well as cloud-native frameworks, including Spring, serverless, Windows containers. It just basically gives all of these options to developers to create the best possible code that they can. All right, I am switching to the next slide. So let me know when you see Trusted Enterprise Kubernetes. And this is kind of more of an introduction slide, so I can quickly click through this if we need to. So we've structured OpenShift enhancements along three main reasons why customers would choose to use OpenShift. So here's where we're going to show you OpenShift in, providing an even better Kubernetes platform. So at the end of the day,
Kubernetes done right.
Yeah. Okay. We're
perfect.
We're in sync. Awesome. The hamster caught up. Okay. So now, Kubernetes done right is hard. This is something I mentioned earlier in the presentation, and just want to give you an idea. You've got different phases as part of. If you're trying to do Kubernetes yourself, you've got the install tasks, you got deploy tasks, you got harden tasks, you got operate tasks, and while it's actually not that hard to download and install Kubernetes, getting it really ready for production, running those business critical apps for your company or your business takes a whole lot more. There's a number of things that need to be pieced together, tested, hardened. Just to give you an idea, so if we're talking just about identity management, Kubernetes, you're going to provide you access to a lot of internal systems, employees, partners, and customers. And you're always going to have these security rules established by your organization and the way to do and how to integrate between Kubernetes and your company's approved LDAP. That requires knowledge of DEX. And so that's the open source IDM system Kubernetes uses that integrates systems to LDAP. Similarly, you need to hook up Prometheus, source monitoring, alerting to hook up another monitoring system so you can get full visibility of Kubernetes ops and testing and production. So as you can see, it quickly becomes, if you're trying to do this outside of just a pet project, and if you're trying to show value in an enterprise or a production environment, it's quickly going to, take up a lot of your time. All right, switch to the next slide, which is OpenShift is trusted Kubernetes. So now let me explain how we build OpenShift. So at Red Hat, we use, and I mentioned this briefly in the beginning of the presentation, 100% open source development model to deliver enterprise products. So there's no forks, no rebases, no proprietary extensions. So our secret source is our ability to turn basically dozens and hundreds of open source projects into, just production ready, stable, and secure products, that we've supported, over the years. So just to give you an idea, when a community sort of declares a certain release ready, we'll take it in-house. We typically find hundreds and hundreds of defects that we fix in corresponding downstream releases. And we can do that because we've been contributing to Kubernetes and many other projects that OpenShift is based on pretty much since day one. And if you look in terms of overall commits, Red Hat comes in at number 2, right behind Google, who's the Kubernetes sponsor, in terms of overall commits. Now, obviously, we're second. Right above us are independent individuals who are contributing to the source code. But in terms of an enterprise organization, we come in right behind at number 2. And okay, OpenShift container platform. Okay, so now I've switched slides. I'm now on the OpenShift container platform. So kind of with this foundation of the trusted enterprise Kubernetes platform, that term again, we've added, enhancements, deliver an application, so all with the intention of delivering a platform with all the components that you would need to get a fully integrated build, deploy, and manage, and be able to manage containerized apps. So in many ways, OpenShift is a smarter Kubernetes because we've also streamlined the installation and the upgrades. So you can be just to give you an example, you can be up and running and fully configured with Kubernetes cluster in less than 15 minutes. And at that point, you have everything you need from metering, monitoring, and cluster level application and dev services. Kubernetes updates, security patches, updates can be deployed pretty much with a single click. Again, that's that over-the-air updates feature. I think I have a slide on that we can talk about. One thing to note is that with the release of OpenShift 4, we transitioned the underlying operating system from Red Hat Enterprise Linux to Red Hat Enterprise Linux 4OS, which can actually update. When you're deploying OpenShift 4, you're not updating different components individually. You're basically deploying OpenShift and having OpenShift configure the underlying components, one of which is the RHEL CoreOS operating system. And just to give you an idea, RHEL CoreOS at the end of the day is a distribution of Red Hat Enterprise Linux. Obviously, there's going to be some slight package differences. And one thing to note is that it's basically a read-only file system. So a lot of the changes you will not be making directly on the RHEL CoreOS operating system. You make them through the OpenShift manager. Now,
hey, George, quick comment about that.
Go ahead.
I talked to some other public sector reps from Red Hat about that and how it's probably gonna be a challenge in terms of securing an OS that's read-only, immutable. How are customers or end users? How do you see them doing that with the way it's going to be configured in CoreOS?
That's a very good question, and I've actually been in a lot of discussions. I know the Department of the U.S. Courts has had those same. We've been in discussions with the CISO there, and there is a series of blog articles that have been released as of, I believe, just over a week ago, which basically walks you through the approach for hardening a CoreOS operating environment, and I can definitely provide that. I can provide those links after today's call.
Thank you. Yeah, that'd be great.
Mm-hmm.
And the thing to note too about an immutable operating system is once you get it secure, like it's immutable. So it's difficult to change. You have to use like a known pipeline or a known process in order to move the change, like new immutable change into place. So hackers, they can't just change a configuration file. They can't restart change the config and restart a process. So it's actually more secure.
Mm-hmm. Yep. Okay, so now we're on the next slide, which is the full stack automated install. So this kind of touches upon what I mentioned before. On the left-hand side, you see how OpenShift 3 traditionally used to be installed and configured. It's a three-step process where you're configuring the underlying infrastructure, the RHEL operating system sitting on top of the infrastructure, and the OpenShift platform, and making sure that all the necessary configurations are set correctly. A little bit on the more challenging side to get up and running. So we took a lot of the feedback that we received from a lot of our customers, and that sort of geared us towards the model that you see on the right, which is OpenShift 4, where we basically use the OpenShift 4 installer, and as part of that install process, includes the RHEL CoreOS as a component of the product, and then the install will configure the underlying provider, then spin up the RHEL CoreOS nodes, and then deploy the Kubernetes clusters and services on it. So you go from configuring 3 separate entities to one full stack automated install process. Over-the-air updates, mentioned this a little bit, but being able to stay abreast on all the new updates that are being provided by Red Hat. Again, compared to running your own vanilla Kubernetes and having to download and manage, all those different components, we're providing that as part of this over-the-air update feature. So it's not only just to simplify the OpenShift installation, but making upgrades seamless, fully automated, and making it, the intention is to be able to upgrade your OpenShift environment as easy as updating, say, for instance, like your mobile phone. So, Matt, I don't know if you had any other comments on this. Or...
No, that's great.
Pretty straightforward.
Yeah.
So in terms of security, comprehensive container security. So you've got static security policies and checklists, no longer are sufficient and don't scale well for containers in the enterprise. So in order to really get, true business advantage of containers, enterprises need to sort of rethink how they're approaching security. In the past, security was something that came at the end once you have your environment up and running, and then you have somebody going in the back end running a hardening script, running an SSScan, running so on and so forth. But with OpenShift 4, being able to leverage a lot of those security features that we've already implemented within the underlying RHEL operating system, you have this ability to very quickly ensure that you're adhering to your security posture. And securing containers is a lot like securing any running processes. You need to think about security throughout the layers of the solution stack before you deploy and run on your container. So you need to think about security, overall through the application and container lifecycle. If you're going to look at securing containers in three major categories of an enterprise container solution, so you need to control the security of the containerized apps. That's the first. That's the top of the slide, and in the middle part of the slide, you have to look at defending the actual container platform, and then as well as extending the security of your overall environment. So leveraging tools from kind of like the broader security ecosystem. And like I mentioned before, we've made a lot of we've already provided a lot of information on how you can secure things like your RHEL Core OS environment. So like I said before, I can provide those after this discussion. Okay, so I believe this is where I hand it off to you, Matt. So I don't know if you wanted to take control of the screen or if you wanted me to run the slides for you. It's up to you.
Hey guys, I have the PDF, so there's also the option I can run the slides, however you guys want to do it. Oh, Matt, you're taking over, okay.
Okay, so Matt, you're taking over, okay. Did we lose Matt?
I think he's on mute.
Hey Matt, you're on mute.
There we go. How about now?
Yep, we got you loud and clear.
Okay. We'll see if my internet and presentation from here is any snappier. Okay, so one of the main ideas of the platform, you might hear the term open hybrid cloud. That term is used as the methodology that Red Hat would deliver a solution, and that solution is built on top of OpenShift as the core platform. So if you think back over the last X number of years, 10 years, 5 to 10 years, one of the things that has enabled innovation to really speed up is access to resources via cloud. And then the key to those cloud resources is that they have APIs that are exposed, and users can request those using automation tooling or dashboards that they provide as well. So having access to resources that are immediately available, it's enabled us to experiment, to try new things. Maybe we have a crazy idea for a piece of software. Before cloud was available, if we wanted to develop that software properly where it would scale, we might have to procure, a dozen or 2 dozen servers. That process would have taken 6 months. That wasn't unusual. So with cloud, we can try it. If our idea is terrible and we realize 2 weeks later this is a horrible idea, we just delete everything through the API and we stop paying for it. Before, when you procured, a dozen, 2 dozen servers, you needed to show value. So you weren't going to take a risk. You were less willing to take a risk when you had a capital expense up front that you had to justify and get C-level exposure, to. So one of the ideas of the OpenShift or Open Hybrid Cloud Platform is we're actually creating a virtual cloud. So with the cloud provider today, we use tools, automation tools, or you can use, the dashboard, but automation is the best method to do it. And we create things through their API. So if we're on AWS, even if we use a third-party tool like Ansible or like Terraform, we write our code to the cloud provider's API. So if we wanted to move that to Azure, for example, we have to rewrite all of our infrastructure and automation tooling in order to support the Azure cloud. So the idea is, rather than hitching your cart to a proprietary set of APIs like AWS, like Azure, like Google, what we can do is we can stand up the Open Hybrid Cloud, which is 100% built on open source software. And we can really leverage the Kubernetes API in order to manage our virtual cloud. So what we're really implementing is a virtual cloud. And then for developers, we can write our automation against the virtual cloud instead of tightly coupling to a specific cloud provider's APIs. Okay, do you see the next slide? A consistent container application platform?
Yes.
Okay, maybe a little snap here. So this is just a high-level visual. OpenShift, as you might know, is built around Kubernetes at its core. The Kubernetes piece is, a lot of people don't know that Kubernetes is actually, it's more like a toolkit. It's not an off-the-shelf like product that you can start utilizing from day one. There's a lot of components around it that you need to integrate into the platform. So this slide gives you a little visual of the different areas where the out-of-the-box solution of OpenShift provides additional capabilities on top of the Kubernetes API. And then on the bottom here, you can see that we support all the major cloud providers, and we also support bare metal or virtualized environments if you have your own data center. So some customers, they may say like, we have too much data, or we already are invested in a data center, like we're not ready for cloud. And what this does is it lets us build a virtual cloud on top of your existing data center. And then if at some future point you want to go to a different provider, it's easily portable. And then it gives us access to those on-demand capabilities via the Kubernetes API or the OpenShift API. So some of the things, as you can see along the top here, it has a lot of automation built into it. It supports multi-tenancy, secure by default. So out of the box, security is enabled. Whereas with like a vanilla Kubernetes implementation, you really have to think that through. And when you build a pipeline, for example, a software pipeline, you have to think through the security components as you stitch it together. Over-the-air updates, it has network policies, and then out of the box, it has a service mesh that you can enable as well. Monitoring and chargeback if you needed to do that internal for your business or per tenants, and additional, plug and play capabilities. So Red Hat provides like a known good and tested opinionated framework out of the box, to start writing code and being as productive as possible. But if there's a piece that you want to change it out for something, that's completely possible. Okay, this slide, the adoption phases. So these are just kind of high level what a migration to a container platform like OpenShift or a Kubernetes-based platform would look like. Typically, the first stage where people start experimenting is with stateless apps. This is the easiest phase. This would be like a web server. where we don't have any data that we need to persist. So if we had a server that, let's say we destroyed it, the system automatically recreates it, and it's identical in an identical state. It's an immutable image or a container image. So that's the easiest one because we don't have to worry about maintaining data. After you get good at doing stateless apps, usually you would start experimenting with a stateful app. So Jenkins might be an example of a simple stateful app where you want to maintain your build history. And what you would leverage is a built-in Kubernetes type called a stateful set. And what that does is it maps your instance to a disk, which can be backed by a cloud provider, a virtualization platform, or a vSAN, lots of different options regarding where the storage actually is. But if that server were to be destroyed, it recreates a new one using the immutable container, and then it attaches the disk. So it would be just like if you had a server, a physical server, with a hard drive in it, it's running, there's lots of data stored on the hard drive. Let's say we have a short in the power supply. We could just pull the hard drive out, put it in a different chassis, and boot it. So that's essentially what Kubernetes does for us. Once we get good at the simple stateful apps, the third stage is more complicated or distributed systems, where we actually have data that we need to maintain, and it's distributed, and the processes in order to manage it are more complex. So data rebalancing is an example here. Auto scaling can actually happen across all three of these, all three of the adoption phases, but upgrades also. And we'll see a little bit about, we're going to talk a little more about these distributed systems here over the next few slides. Okay, so Red Hat is very heavy on the term operator, if any of you have heard that yet. Red Hat talks a lot about like our operators, our operator marketplace. And what an operator is it kind of addresses that third phase back there. When we have complex applications that we want to deploy to our OpenShift cluster. So we want to deploy that application into there. But some of the processes are like process heavy, I would say. So these along the top are some of the, it's basically to categorize where some of the processes might happen. So an operator is an application that we deploy using what's called the operator framework. And that operator can handle the installation itself of the application. Deploy kind of goes together with me. So no matter which platform, it will install and configure the application. It can do things like security hardening. So it can configure the OpenShift environment so that it's in a specifically known good and secure state. And then some of the, what I would call like ops tasks, those processes are actually in code within the operator itself, and the system knows how to manage those tasks. So as a hypothetical example here, George mentioned earlier, I think he talked about the over-the-air upgrades. So typically, if we wanted to scale out, let's say we had 10 worker nodes and we were experiencing a high load on our system, we would have to figure out how to boot additional nodes. We would have to install the software. We would have to configure it. And then we would have to join it to the cluster, which means we're inserting data in the database so that it knows about new worker nodes. So that entire process can be automated. So we'll see some other slides here in a bit. But what this does is it allows you to manage the cluster nodes themselves, for example, or let's say databases as well. So if you install a Postgres database within the cluster, you might request that through the API. So you would, as a user, say, hey, I need a Postgres cluster. It needs to have 3 nodes. And what it does is it installs those 3 nodes for you. It makes sure that they're on redundant hardware so that they're not going to be vulnerable to failure of a single piece of hardware. And then what it can do is going forward, it can actually manage database migrations or schema changes for you across all those nodes. So those are a couple examples. This one here, we just mentioned the operator framework. It mentions on the bottom, it codifies the operational knowledge. So like how do I need to do a Postgres schema change? We can do that. We create the schema change, and then basically we upload that through the API, and then OpenShift itself takes care of implementing that change across all the databases in a way that won't affect our service. And same with if we wanted to upgrade the cluster, like logically there are steps that we would do in order to prevent a service outage. We would boot a new host, we would install the software, we'd configure it, we'd join it to the cluster. And then we would take one of the old nodes and we would drain that node, and we would move those containers to the new node, and we would monitor and make sure they moved. So like when we say codifying the processes, that's what the operator does for us. It's kind of auto magic. I mentioned an operator hub. So similar to if you've seen the AWS marketplace, or any marketplace for that matter. We have Red Hat certified operators that you can just do one-click installs with. And we also have a third-party marketplace or community operators where you can install those with one click as well. Here's just a picture you can see. So these are handled by the administrator, because what an operator is doing is it's expanding the Kubernetes API. So in my opinion, like the most powerful part of Kubernetes is its API. And what Red Hat does in OpenShift is it's built out this operator framework so that you can snap in new applications. And like, for example, I was helping earlier today with Keycloak, which is an identity provider. So we actually installed that through the marketplace, and then we could create a new identity provider by just creating the type Keycloak.
Hey, Matt.
Yes.
Yeah, on the previous slide, you had operator certification or OpenShift operator certification. Can you quickly touch on that?
Yeah, you bet. So I don't know the details on it, but there is a program for, what is the term we use? Do you know, George, ISVs, is that what it is? Partners that write software, basically. They have the ability to package their software into an operator. And that gives you like one-click installation capability to install that service into your cluster. So there's a certification process. I don't know what the testing looks like, but if anyone's on the call or anyone wants, additional info about that, we could definitely get that for you.
Got it. Thanks.
Yep. Okay, another important area where Red Hat has really done a lot of work is making the developer experience itself as seamless as possible. Most developers don't want to worry about managing load balancers or IP addresses or DNS. They just want to write code. They want to know what button to push or where to check it in, and they want to see if it worked or not. So we've actually developed quite a few tools around the developer experience. We have a standard dashboard, which an administrator would use. That would be more like an infrastructure platform oriented person would manage that more on a day-to-day. And then we actually have a pull-down menu where you can go to a developer experience. And it's greatly simplified. You don't have to see any of the infrastructure related things. this field here, you can see they installed the MongoDB operator, and it gave them the ability to create under this kind here a MongoDB replica set. So under the specifications here, spec, we can see they're requesting 3 servers, the version. They don't need persistence in this case. That means if the nodes died, like the data would not be saved. So it would be based on the replication between the 3 nodes. And then they name it and give it their credentials. We also have a couple other tools. I think they're on the next slide, but let's just see. Oh, I guess we're gonna go into that here in a minute. Okay, one last area before we move to the next section, which is the developer focus, is what we call Advanced Cluster Manager. It's actually, I don't see that word on here, but it's called ACM, or Advanced Cluster Manager. And what this is through the cloud.redhat.com portal, we can manage any number of OpenShift or Kubernetes clusters so that we can keep our configurations and our format and how we do things consistent across all of those clusters. We also have the capability to launch new OpenShift clusters via the cloud portal. So it's just menu driven, choose your cloud provider. If it's Google, you click Google. It gives you a pull secret and you hit go, and it creates it for you. Okay, so this last section is for developer experience. This is kind of a visual, this slide here, just to show you how crazy some of the choices can get when you have to make this. So if you wanted to build your own Kubernetes cluster, the platform is kind of where you would start. I'm not sure, can you see my mouse?
Yeah.
Okay, so the platform, that's the easiest choice. That gets you out of the gate. You have to choose how are you gonna do your logging? Are you gonna do distributed tracing, which is something that OpenShift has out of the box? How are you gonna do event driven? Do you need serverless technology? What continuous integration tool are you gonna use? So this gives you a visual of the different areas where Red Hat has pulled together from many open source projects and done, the extensive testing, integration testing between all the components, the integration itself, obviously, and then made such a good user experience. Okay, so this out of the box theme, in a past role, I was a platform engineer, we started with vanilla Kubernetes and started building around it. It took years, right? That process of making all these choices that are back here. So what it allows you to do, OpenShift, out of the box, all of those platform decisions are already made for you. If you have a really strong opinion, you can change them in and out relatively easy. They're like little Legos that snap in and snap out. But what it allows you to do is to focus on your business application. So wherever it is you're writing code that adds value to the business, that brings in revenue, you can start doing that from day one out of the box. So you get you get all of the APIs. So similar, like we mentioned earlier, to a cloud provider, if you need a database, you hit the API for a database. If you need a new compute resource, same thing, through the API. And we also have a really nice dashboard as well for the people that prefer to work out of the GUI. It has a lot of this automation built in. So CI/CD pipelines, build triggers, which automatically kick off builds, which can trigger and kick off deployments as well. It has a structure to do configuration management, and it also has centralized logging so that you can go in. If any of you are familiar with Splunk or with Sumo Logic, this uses Kibana. But it's a visual experience to query and correlate data across all of your applications. These are a couple advanced ideas. These do come out of the box, ready to turn on, pre-integrated, pre-tested by Red Hat. The OpenShift service mesh, or Red Hat service mesh it's called as well. It's built on top of Istio. It also integrates Jaeger as well as Kiali. So those are distributed tracing tools where you can actually visually look at a transaction or a user experience and see where the most time was spent, like on the database query or on the web query, or if there was latency across the network. It's a great tool. It also is another conversation, but it really allows you to abstract away the routing logic and the failure logic. So like if you have a failure, some of you might be familiar with the term circuit breaker, like we can pull all that code out of your business code and we can manage it as part of the infrastructure. Also on the bottom here is serverless. Serverless, function as a service, or Lambda are the terms that most people are familiar with, if you've heard of that. That allows us to, it's good for two different things. One, it's great for an event-driven architecture, which could be another hour conversation, and why that is hugely beneficial. But then the other thing is it makes it easier for developers because they can write simple, task-oriented code and make that available on the system as a function, and the function will auto scale. So they don't need to worry about how many instances do I need to run. All they need to do is to say, I need a response under X number of milliseconds. And when there's a huge load, the system will auto grow that for you. When there's no load, it'll do the reverse and auto shrink it down. And if you want, it'll actually turn off instances to save money. I've seen that used in like an integration testing environment a lot. Okay, along the idea of developer experience, George mentioned this earlier, code-ready workspaces. What those are is it's a complete IDE in a web browser. So it's kind of like a virtual desktop for a developer. So they have everything that they need to write code, for syntax highlighting, for linting, and for compilation of code. And what they can do is push that directly into a repo, which will be automatically built and deployed within the Kubernetes environment. So this can save a lot of time because the developers are developing against Kubernetes or OpenShift from day one. In some environments where I've worked, like we would use Docker on our machines, we would use Docker Compose to do our testing, and then we would put it into the Kubernetes environment. But it's different, it works differently. There are errors that get introduced, when you change from using a laptop with Docker to using a Kubernetes cluster. So this gets rid of that, and it lets the developers start writing code from day one against Kubernetes or OpenShift. This other little tool here is pretty handy. I mentioned the developer portal or the web page. This is actually a developer command line. So some of you may have heard of kubectl, kubecontrol, kubectl is what a lot of people call it. The OpenShift version of that is slightly expanded. It has more capabilities. It's called OC. And we have a developer specific version as well. It works more like Git. So it's very application focused and very developer friendly so that they can write code and push it and build it really quick. And then on the bottom here, we have many plugins that we've written for the common developer environments here, such as IntelliJ, JetBrains, VS Code, Azure DevOps is great as well. And then Eclipse. We kind of talked on this, code-ready workspaces. It allows you to do everything via the web browser. if it works for your environment, it's definitely great, and it has the potential to save developers a lot of time. And was this where I was supposed to hand back here, George?
Yeah. If you don't mind, if you can run the slides just to cut down on time, and
you bet.
I don't want to test the internet gods with my slow connection. So
all right, I got you.
So if I'm just going to go ahead, I'm looking at the clock, and I just want to make sure that we're giving enough time for Dave to do his part as well. So I'm just going to go through these slides real quick, and then we'll take some questions, and then we can continue on. So just sort of bringing this back more from a business perspective, in general, what we've seen with some of our customers that are deploying OpenShift, that have OpenShift running in production in an enterprise setting, we're seeing quite a few things, especially when it comes to the feedback that we're getting in terms of ROI, so return on investment. We're seeing, and these are basically a subset of feedback that was provided to the IDC. And in general, we're seeing, for those people that are deploying OpenShift, there's 66% faster development life cycle. So like I said before, being able to get more applications into production, and overall more applications per year. So being able to see, and that also extends to, the monetary side of things. So additional annual benefits for 100 developers as well. So you're going to see that, and we've got, like I said, we've got multiple use cases, multiple case studies that we can touch upon there. So Matt, if you can just go to the next slide. And this is just a smattering of some of those customers. Obviously, you don't have to get into too many details there. One thing I did want to touch on this slide was that not only do we have the on-premise OpenShift cloud solution, but we also are working with a lot of our partners in the public cloud space, AWS, Azure, and Google Cloud, to provide kind of these managed service OpenShift offerings that we're providing hand in hand with those public cloud offerings. So I can speak from the Azure side of things because I also help to manage that partnership. We've got a jointly managed Red Hat OpenShift offering where the difference here is that if you're looking for an OpenShift offering that is not as, if you don't want to have to be responsible for a lot of those OpenShift day-to-day management of administration tasks, you have the ability to leverage the managed service offering, and you can have a kind of like a pay-as-you-go model. You can use reserved instances within the public cloud. But as part of this slide, I just want to be able to show that when it comes to OpenShift, there are all sorts of different options that you have at your disposal. It really depends on how much interaction and how much administration you want to have. Now, with regards to the slide now is, in talking about Kubernetes, there's always, when Kubernetes started to gain a lot of traction, a lot of the public cloud started to jump on the Kubernetes bandwagon and started to develop their own Kubernetes offerings. And we kind of like to refer to them as the XKS services. So obviously you have EKS for Amazon, you have AKS for Azure. I'm not exactly sure what the GCP or the Google Cloud is, but I'm pretty sure they have a Kubernetes offering. And what this slide is just trying to illustrate is that you have an XKS service that sits right in the center, and then everything that surrounds this is all the additional benefits an OpenShift platform provides you. And one thing to keep in mind is with OpenShift, you're focusing more on providing business value. You're not spending a lot of time on the actual management of the technology. So that's one of the main benefits here. Going back to that model of, or that, the overall why for this discussion is trying to get those applications faster to your customers, so you start to see the benefits, through additional revenue and so on and so forth. These are just some added benefits when it comes to managed OpenShift offerings. So like I said before, reduced operational overhead. being able to get spun up really quickly. So you can start up a managed service based on OpenShift in minutes, and obviously that management overhead is pretty much reduced. You've got SLA, being able to because a lot of the OpenShift managed offerings are in many cases jointly managed by both Azure and Red, or Microsoft and Red Hat for that managed offering, or AWS and Red Hat for the AWS offering. You've got a collaboration when it comes to the support experience. So you actually have, just as an example, you have Red Hat engineers actually working in Redmond, Washington, right next to the Microsoft engineers to make sure that when a support issue comes up, we're working hand in hand to address the problem. So that's a very unique, offering there that, just continues to provide additional value. And again, being able to empower developer productivity and also just a focus overall on consumption-based pricing. So at the end of the day, you are using on-demand instances and or reserved instances from the public cloud. And why is Red Hat the best choice? So this is another one of those handy-dandy marketing slides. So it's, code, customers, cloud, comprehensive. A lot of this stuff we've already covered. We've got obviously the number of commits that we perform on the Kubernetes project, all the customers that we like to tout, the clouds, the public clouds through our partnership program that we work with, as well as, an overall comprehensive portfolio, and being able to leverage some of our lessons learned from the Red Hat Enterprise Linux product, and a lot of the things that we've taken from that in order to implement a lot of these security features and additional capabilities. And this is sort of the same kind of thing, talking about the whole concept of the trusted Kubernetes, enterprise Kubernetes, again, cloud experience. And again, that's the whole theme about empowering developers to innovate. So this is kind of just bringing it all, putting a little bow on it. And for the last couple slides, just wanted to touch briefly on some of the noted OpenShift capabilities. Now, OpenShift 4.5, which is the next release, which I believe is slated for, I guess, in a few weeks. Is that right, Matt? Or is it already out? OpenShift 4.5?
Yeah, I believe it is the end of the month or first of the month.
Yeah,
July.
Yeah, that's correct. So we wanted to, for this slide and the next slide, we just wanted to show some of the features that we have on the roadmap for OpenShift 4.5. If you go to the next slide, we even go into further detail with regards to, all the different developer application, platform, and hosted offerings and features that we're planning to offer as part of the different releases. Obviously, OpenShift 4.6 is going to have some additional things. Now, the only thing I would caveat here is that these are currently planned. These features are currently planned. Doesn't necessarily mean that maybe one or two may shift to a future version, but depending on any issues that the BU or the business unit runs into when it comes to creating those capabilities. So, but this gives you an overall pretty good picture of some of the features and some of the integration points that we're looking for future versions. And I think with that, we are at the end of the presentation. So any questions that Matt and I can answer?
Or I don't know, David, if you had anything you wanted to show, and we can just chat at the end, however you want to do it.
Yeah, if anybody has any immediate questions, or I've only got 3 or 4 slides I can go through really quick around security and our managed service offering, and then we'll see where we are with questions. Does anybody have anything right now? Okay. Price. Somebody said, what's the common price here? I guess it's probably a really open-ended question for you guys to answer, because it really depends on a lot of things, right?
Yeah. So just to give you a general sense, So when we're talking about the on-prem OpenShift offering, OpenShift container platform offering, we typically do based on the number of cores that the nodes, the application nodes for OpenShift are running under. So we typically, just to give you an idea, so if you have a 16 core subscription for OpenShift container platform, using premium support, so that's 24/7, gives you access to support, the knowledge base, and advocacy from solutions architects and what have you. You're looking at, with regards to MSRP, again, this is before any kind of discounts, before anything, and any other partner discounts on top of that, and if there are any GSA discounts, you're probably looking somewhere in the realm of $20K or so. And obviously that scales up based on if you need additional cores or if you prefer standard, but typically that's usually a good starting off point.
And just to be clear, that's a cluster with 16 cores, right?
Correct.
Okay.
It's 16 cores or 32 vCPUs.
Gotcha. All right. If no one has anything else, I'll go ahead and go through my slides. Let me share my screen. All right. So in the DoD world, the term SecDevOps is pretty common. I'm sure some of you have heard DevSecOps, but the reason they say that is because security is really a primary focus on a CI/CD environment, a platform. So most of the stuff I'm going to be discussing today is around the tools. This is obviously a pretty broad subject, and we'll probably do a meetup specific to a handful of security tools or just one. So why use more than one security tool in the pipeline? And I've heard some people say, well, I have Prisma Cloud or what was Twistlock, and that handles all my security, and that's enough for us. And there's obviously a lot more to security than just scanning an image of your container and letting you know what type of vulnerabilities are there. So in the environment we've supported with the DoD and some other environments, there are different layers of security. One of them is focusing on the source control and the container image that you build out and that you store in your environment, and that can be on public internet or that can be in your local image repository. It can also be the security in your runtime, so the actual containers or pods that are running within your environment, and the traffic within your cluster, the ingress, egress, or inside and outside of your network, and then the security compliance rules that you need to follow in order to be compliant with the organization that you work under. And specific to NIST, there's a 800, 190. There's a handful of others out there that I'm sure are being worked on, especially around immutable architecture. I had a question about that before with Core OS, and I'm sure NIST will come out with something in the future in regards to that. So for container image scanning, I'm pretty familiar with Prisma Cloud. The environment we support now uses Twistlock and also with Sysdig, sort of similar products. So with that sort of security tool, you're scanning the different layers within your container vulnerabilities, and they're basing it on a database of vulnerabilities, and you get a report, or you have quality gates within your pipeline that will either pass or fail based on a score or on a finding. If you have something that's highly vulnerable, it will not let your image actually be built and deployed into your registry, and provide some sort of output and tell you, hey, you really have to fix this before you go to the next step. And then there's component scanning. So if you're pulling down a lot of open source libraries and dependencies, there's tools like Nexus IQ that will break down specific components within your containers and let you know which version is vulnerable, and if you go up or down a version, what sort of vulnerability you'll have, or even in terms of licensing, if you have a license that might make it public to everyone out there, if based on inheriting that license, then you probably don't want to use that within your environment if you have a lot of concerns with security. So there's a whole lifecycle management part of that that Nexus IQ can handle. And the next one is source code scanning, and I'm most familiar with SonarQube. I know there's a few others out there, but this type of security is more so on your source control, and what sort of code quality your developers are creating, and it'll do a static analysis on the type of code that you're putting out there, and any specific vulnerabilities, or even SQL injection, that sort of thing. And it does the same sort of quality gates in your pipeline that will provide reporting or a pass-fail type of logic. The next one that I'm not as familiar with, but I know is great for forensics, is runtime scanning. So if your system's running real time, monitoring what your container or what your application is doing can be critical if something is happening, sporadically, and it's not something that your monitoring system can pick up, or it's not a vulnerability that your image scanning is picking up. This would be like a real time in your file system or in the kernel that's running within your container would be captured. So that's kind of an unknown one that I really don't have too much experience with, but it's great for forensics. Container compliance, like I mentioned, some tools out there will actually tell you if your containers are compliant, your environment is compliant for specific controls. And for monitoring, a few of these are mentioned, Grafana, Splunk, and some other tools that will let you know the health or how well your environment is running. So for Dell Technologies, our value-added managed services, similar to what George was mentioning, we can support multiple cloud environments, and we're cloud agnostic when we deploy our environments. We also have a data center deployment in our cloud that supports VMware, various other hypervisors. And one of the important things to note here is that our ability to direct connect to those cloud providers. So versus being on the internet and routing all your traffic through the internet, you can have a direct connect option with AWS, Azure, GCP, and your connection speeds can be dedicated between 1 gig and 10 gig private connections from your cluster into your cloud environment. So with our managed service, we also include some of the security tools that I mentioned, specifically Sysdig and the Nexus Repository Manager and IQ Lifecycle Manager. So to build a full security lifecycle environment, we provide those tools out of the box and under one support umbrella. So we have personalized tier 1 support for your infrastructure, your container platform, and your full stack. And we're also experienced with highly regulated workloads with a DoD and public sector, where security is really important. So I don't really have a big demo to show here, but I did want to show that you can deploy OpenShift within your local environment. And unfortunately, I only have version 3. There's not a whole lot that's different from what I'm going to show versus OpenShift 4. But what I've done is I've installed MiniShift, which was what was used in version 3.x. And I'm not sure what it's called now for 4.x, but there is the ability to launch a OpenShift cluster within your local environment.
It's called CRC, or Code Ready Containers.
Thank you.
You bet.
Lots of acronyms.
Totally.
So I just have a console up here of what I've done to launch the MiniShift environment, and it's a lot of output here, but basically you launch MiniShift, it tells you where your environment is and how to access it. And let me bring up the web GUI. And you get something like this. And I've already got an application deployed here. And I followed a really simple Red Hat tutorial that shows you how to quickly start MiniShift and deploy a sample application. So once I got past actually deploying it, out of the box you get a full environment where you can actually deploy your application. And you can see my deployment here. It's just a Node.js application. To run that, I basically log in through the console. I capture my login command, and that's what you get. You output it, and I captured a GitHub project for Node.js. And where's my deployment? It gets deployed within OpenShift, and you can go back here and see the application actually running in the environment. And it tells you that it's active and you have one replica running. And after I run that, you have your pods that are running within the environment, and you can actually go to the terminal within your pod and run any sort of logging or commands that you need to run, or you can click on logs and actually see the log output for the application that you're running. And here's the actual application that's running in the background. It's just a Node.js application. But all that was done within three or four steps. It was very simple to set up. It took less than 10 minutes to launch MiniShift and get online. So what I wanted to show here basically is how simple it is to get the whole entire environment set up locally and start developing something. So obviously I ran through that really quick, but OpenShift breaks everything out logically. If you want to look at what you actually need to build and where you're pulling the source from, you can see that in here. If you want to see the image that gets created once you finish your build, it shows you in here where it's stored, how to actually push it into Docker. And that's pretty much it. And I will post up a link to this quick start guide and the GitHub project, which I've got up here, for the two things that I've done. And you can try to do it with OpenShift 4, but I'm most familiar with MiniShift, so I'll post those instructions. If you guys have a link for the a quick start guide, that would be great. I can include that as well.
Yeah, I can grab that real quick.
So based on what you're seeing in this call today, first off, would you recommend a developer environment to be set up this way to get the experience going? To run a desktop version of OpenShift to get their feet wet?
As a starting point, definitely. It's essentially the same environment that you're interacting with. It's just not as scalable and enterprise ready. So in terms of...
But I should be able to shift my workload that I create on this desktop version of OpenShift. I should be able to then migrate it to, let's say, the company dev environment, wherever that is. Let's say it's on, Amazon.
Yes, absolutely.
So creating those practices and shifting between environments, is there some type of best practice that is shared about how to work with these environments?
George or Matt, you guys want to answer that one?
Is there a certain area you're interested in?
Well, first off, most of my problems that I deal with is around architecture, and that always comes into money.
Sure.
First off, nobody wants to pay for the Amazon bill. So they want to keep it off Amazon as long as they can keep it off Amazon. As soon as you get your dev done, you get your Helm set up and you're set up on your Kubernetes on your own desktop. Okay, fine. Shift it out, deploy it.
Yeah.
And then I want to know about like the scanning of the containers, because when you're talking about scanning the containers for vulnerabilities, they're both static, so to speak, that you were talking about for being regulatory compliant as well as just scanning for vulnerabilities, correct?
Well, there's the source scanning as well. So if you're scanning your source code and you're scanning your images, images are more static, obviously, but there's also a runtime component. And I mentioned Sysdig as being one of the tools, but there's various other tools out there that will do runtime as well.
Okay. I was just wondering if you could discuss how much configuration you have to do to actually get the regulatory piece kind of like running for a company.
That really depends on the tool that you're using. My experience with Sysdig has been pretty good in terms of the compliance component. They have templates within the environment that already have 800.191 NIST controls in there, and PCI and a few other frameworks, security frameworks. And you can actually create your own framework, to set up your own controls. But most of the vendors that do that sort of thing have, the most common templates built in. So once you get it linked within your cluster environment, usually it's kind of an automated thing and it's ongoing.
Okay, thank you.
George or Matt, do you guys have any comments on the ability to go between a localized environment and an enterprise environment, or dev and stage and production best practices there?
I would say there's not necessarily one, there's infinite ways to do it. So it kind of just depends. I think you were alluding to that as well, David. It just depends on the environment, on the compliance requirements. There's so many pieces, but just in general, if one thing to note about running the code-ready containers locally on your laptop, I think they take it's done in a virtual machine, and it takes 8 gigs of RAM. So if you have 8 gigs of RAM on your laptop, you're dead in the water to start, right? So your experience, if you can build a small cluster and you don't have a beefy laptop, is going to be much better. If you have a virtual machine that you can install it in, or a cloud provider. But as far as the strength of containers is that they are immutable, and when you write your automation around them, that container is static, the container itself. So moving them between environments is seamless. And if I can run it on my laptop, it's going to run. It can run in Kubernetes, right? But like I mentioned earlier, if I'm running it without Kubernetes, there might be a small transition to figure out configuration, how does it work on a Docker laptop installation versus a Kubernetes installation. But if you're running Kubernetes local, you're making your life much easier because you're developing directly against Kubernetes, and that's going to port so much easier to your production environment.
Well, yes, I agree with that. But when we're looking at OpenShift, the fact that, first off, some of the advances that we've actually seen documentation for in version 4 is that you're going to be able to manage VMs, as well as the fact that you can include, through various cloud providers, the ability to integrate into their TPU, GPU environments.
Totally, yes. Those are both true statements. And that can all be done via the API as well, which is great. If you're doing it in-house, you after you install the operator, you have a virtual machine type, and you just write your YAML file and OC apply and call your YAML file, and it creates that for you.
This is the last sticky point, because I said one of the things I deal with is money. Is there any FinOps idea that goes into this to say how much of my OpenShift is consuming on my cloud provider?
How much of your OpenShift is consuming? I didn't quite follow the question.
How much money am I consuming on when I deploy my OpenShift, no matter how many cores, disk, whatever I consumed on my deployment? Is there a way that OpenShift can report back to me how much money am I consuming?
That's a good question,
Yeah.
because the whole monitoring and chargeback thing is new to 4, I believe.
Yeah.
I don't think that's a component in 3, so if you guys can touch on that.
Correct. Yeah, that's available as an operator in 4. So there is a like a billing interface that you can install, like a
Oh,
one-click
I want
install
that.
kind of thing. So
I need that.
and then
I
like
need
you can
that.
do bill back within the cluster.
Well, we want to give it so that the developers understand how much they're consuming.
Yeah, totally. And I mean, I've found that making that information public, like sometimes people are concerned about shaming, and that's not the point. By making
No,
it public and like understood, like everyone wants to be a good citizen and they're more responsible.
thank you. Please put the link for that operator out there, please.
You bet.
I want to make another comment about the automating the deployment to different clusters too. A lot of that can be done through your pipeline, the way you have it set up. And if you're using a certain branching strategy or tagging strategy, you can say, well, only my dev environment's going to go to the lower cost cluster, or to my environment that is static and on-prem, and then maybe my production will go to cloud. Some of that can be built in, or a lot of it I think can be built into your pipeline, and cost can be controlled that way as well. Just building in the logic into your pipeline that will base it off of your branching, your tagging strategy, or the name of your deployment. Does anybody have anything else? Okay, so just to close things out, we do offer an enterprise cluster trial in AWS or within our own cloud in the Virginia data center that we have. You can register if you registered for the event today and we have your information, great. If you didn't register, go ahead and register on the link that's on the screen right now, and let us know, and we can definitely get back to you and let you know what's required for a trial. Our production environment will not be available until the 3rd quarter of this year. That's our planned deployment. And if anybody has any questions about that, please feel free to send me a message. And I want to thank George and Matt. Really appreciate you guys taking the time and giving us all this knowledge. And Fred, did you have anything else you want to mention?
Nope, I'm good here. Just like Dave said, thank you, Matt. Thank you, George. We really appreciate you guys coming in to talk with us.
Absolutely, yeah. Thanks for having us.
Yeah, it's a real pleasure for us to do these kinds of things, these types of engagements. So yeah, thanks for giving us the opportunity.
Awesome. I recorded it, so anybody that registered for the event, you will get a link for the recording, and anything else that was mentioned between me, George, or Matt, we'll post up the links that we mentioned and make it available to everybody. All right. Thanks, everyone.
Thanks, Al.
Take care.